Hello everyone, and thanks for joining me again. This is the first video in a series of videos that will make up a tutorial on how to build a full stack Apollo GraphQL application using React and Node. The only prerequisite for this tutorial is that you do have some experience building full stack applications using both React and Node. For example, you can set up an Express server on the back end and you can render your views on the front end with React. You don't need to know anything about Apollo for this tutorial. We'll cover all that. But you probably should know a little something about GraphQL, what it is and why you should use it. If you go to graphql.org, you'll find that information. So we'll be using the Apollo platform, and it has two components, the Apollo server and the Apollo client. And for the next several videos, we'll be focusing on the Apollo server. And the Apollo server is a GraphQL server, and what a GraphQL server does for you is it creates a graph for your application and allows you to build an API to connect to it. And it provides you access to the data that your app needs through a single GraphQL endpoint. Now, you might already be stuck on this right here, wondering what a graph is. And I won't embarrass myself by trying to explain in detail what it is. If you have no experience with graph theory, you could check out the Wikipedia page on graph theory. But if you don't have a background in abstract mathematics, you might find it a bit daunting. That being said, if you are interested and you want to learn more about graph theory, MIT OpenCourseware has some excellent video lectures available for free. And they cover graph theory from the very basics to advanced concepts. So if you do have time and you have the interest, do check those videos out. So for now, if you want to, you can think of this graph as a sort of magical cloud that wraps your application. And it contains all the data that the client needs, and it has it in exactly the shape that the client wants it in. And so as usual, you'd have to think about making some sort of external API call, for example, if you wanted to get some data from a remote source. And in this project, we're going to be getting data from the U.S. Geological Survey. We're going to be using their earthquake catalog to get some quake data. Right, so if we made an API call to this source, then we would have to wait for the response, and then once the response came in, we would have to process it and extract the data that we needed and then make sure it was available on the client side. And we'll still have to handle that, but we'll do it within our GraphQL server, and we'll make it so that our GraphQL server will do the work. That means that when you start up the server, those calls, those API calls are made, the responses are gotten, and they're processed, and the necessary data is extracted and put into the shape that we want it to be in for client-side queries. And all that'll be done by GraphQL. So that means that when a query is made on the client side, there's no wait time for the response. The response has already been processed. So that means there's no wait time for the processing either. The only wait time there is for the data to be gotten from the cloud and presented. So since your your API call and the response processing are handled basically at the time that the application starts running, the server starts running, you've eliminated a lot of time by the time you make a call on the client side, you've eliminated some of the wait time necessary to process those responses. So it makes your application a lot faster and more performant. So like I said, on the client side, your requests will hit a single GraphQL endpoint. Of course, developer teams will have to think about what kind of data requests will be made on the client side, and then the backend developers will have to go ahead and set up the GraphQL server so that it returns the data that is needed and in exactly that simplified, customized way. It seems like magic, but it's not, although there's probably a lot going on under the hood that maybe most of us would have a hard time understanding unless we spend a significant amount of time studying it. I think because there is a significant amount of work that needs to be done on the back end to make the whole thing work effectively, there is a bit of a learning curve there, and it's a bit daunting for relatively inexperienced developers, which I think makes them hesitant to adopt the GraphQL technology. But going forward, predictions are that GraphQL will become an industry standard in the near future, and I believe that's true. And I think once you get your head around it and you get used to working with it, you'll find it a lot of fun, and you'll enjoy working with it, and you won't want to not work with it going forward. So yeah, I hope that you'll stick with us through this whole tutorial. So anyway, let's get started. Let's go to the Apollo docs site, and if you just go to apollographql.com/docs, there's a little bit of information about the Apollo platform, but for now let's just go right to the tutorial and go right to part 1, build a schema, and set up our Apollo server. So the first thing we need to do is start a project. All right, and we'll do that in VS Code. Sorry about this, it's taking a little bit of time to load here. Okay, so go to your directory of choice wherever you want to put this project. Alright, and then let's make a directory for it. I call the project Quake Hunter. You can call it whatever you like. Give it some other cheesy name. And we'll have to initialize it. And then we'll need 2 dependencies right off the bat. We'll need Apollo server and GraphQL. So install those. And while those are installing, go ahead and bring that project into our workspace. Good. All right, and if we go back to the tutorial docs page, you can see that right off the bat we'll need an index.js file. All right, and for that they've given us some code already, and we'll be using the code at Apollo Docs in this tutorial to bootstrap our project. So let's go ahead and create a server directory and a client directory. Like I said, we won't be dealing with the client side of things for a while, but at least we can have this in here as sort of a placeholder. We'll also need 2 files, the first one being index.js and the other one being our schema. We'll call it schema.js. So for now, in the index.js file, paste in this code. Alright, so you see that we bring in the Apollo server and create an instance of it. That's done right here. And we pass as a parameter our type defs. These are type definitions, and they'll be brought in from the schema file, but we don't have them yet. So now we'll go ahead and write our schema, and that means we'll focus on our type defs. And these type definitions focus on GraphQL types. Let's go ahead and just put this code into our schema file. Right. So for example, in GraphQL you have the query type and you have the mutation type, for example, and say the query type deals with GET requests. So if you're thinking about building a RESTful API and your typical CRUD operations, the read would be your query type. And then your create, update, and destroy would be your mutation type. Alright, so we'll go ahead and define those types now. And we need to do so between the backticks here. Alright, you see there are backticks that have been given to us. And we'll be using what's called the schema definition language. And this is a simplified way of writing GraphQL types, queries, and such. If you use the, I guess what you might call the vanilla GraphQL, I don't want to call it language, but well, here they do use the schema definition language, but they also in some of their code they use the vanilla GraphQL, which is a bit more verbose. So we'll be using the schema definition language, which makes things nice and easy, and I think it's fairly intuitive. So anyway, we'll add in our first type, and it's the query type. So go ahead and copy that from Apollo docs and paste it in. And as I said, we're not going to be dealing with, we're not going to build the same application they built at Apollo docs. We're going to be dealing not with launches but with earthquakes. All right, let's just move all this in a little bit. All right, so first what we want to do is we want to get a list of quakes. All right, that's our quakes query, and it returns an array of quake objects. And we'll also have a quake type that we need to define, and we'll do that coming up. Also, we'll need to be able to query an individual quake. Right, and of course its return type will be a quake. Down here you have this me query, which just basically gives you information about the current user. You'll see that for both quakes and quake, these two queries, well, at least for quakes, you have the return type as an array of quakes, and it has an exclamation point, which means it's non-nullable, which means that it's required. If you don't have anything to return, you're going to get an error. Or if the response is null, you're going to get an error. All right, so let's move on to the next type, which for them they called it a launch type, and we're going to call it a quake type. Alright, so for our quake type, our fields are going to be different. We'll keep the ID field, but we won't have a site field. We'll have a location field, right? And that'll be a string value. Our value will be returned as a string. We're also going to have a magnitude for the earthquake's magnitude, right? And that will be a float. Right? And then we're going to have a time, or actually we're going to call this when, right? And this will be a string, and this will be actually a string of information talking about when this happened and what time it happened at. And then we're also going to have a time property here, and this will be also a string. And we're going to use this as a timestamp so that we can implement pagination later. So for now we'll leave this as it is, and we'll look at our next type. And our next type is going to be the user type. Okay, and we'll also add a username field, which will be a string. We should require it. Also, we need password. And we'll require that as well. So again, with these exclamation points, we are looking at required fields. These are non-nullable, and if you get a null response, that means that you're going to get an error. Now, and by default, these GraphQL types are nullable, so you can make them required by adding the exclamation point. All right, let's continue. We have another type we have to worry about. That's the mutation type. So add that in. So we're not going to be booking any trips. We are going to be saving a record, which means if we find a particular earthquake of interest, then we are going to add that record to our list of records. That list of records will be attached to the user profile. And we're only dealing with a single record, so we don't want it to be an array. And our response will be what we're going to call a record update response. And we'll have the same response for this other mutation, which we're going to call delete record. Okay, and it takes in a record ID, and its response is a record update response. Now, record update response is a type too, and we'll have to define that in a second. Okay, we'll change our comments here. We'll say if false, saving record failed, and here if false, deleting record failed. Okay, and then you see down here we have the login mutation, and you'll be using this a lot in your GraphQL applications. Okay, next. The next type is what we're calling the record update response. Let's put that in there. And basically this type has these three fields. The success field means it's letting you know whether or not you were able to update your record, right? And actually, back in our user type, we have to fix that. We're not saving trips, we're saving records, right? And our records is going to be an array of Quake events. So down here, we'll have to call this records. So we'll be returning a true or false value that'll let us know whether or not we were able to update our records. And then if we were able to update it, then our message will be, it will say, yes, you were able to update your records. And if we weren't able to update it, meaning this response was false, then it'll say unable to update records. And we'll also return the list of records, or sorry, the list of Quakes. And that will let us know currently where we're at in terms of what we have saved to our profile. Okay, so now we're going to run our server, but before we do, we need to add one last little bit of code to our index.js file. So let's do that. And if you've satisfied the prerequisite for this tutorial, then you've set up servers before in Express, and this probably looks somewhat familiar to you. Also, let's add a custom script for running our server in our package.json file. Alright, so we just want to be able to run our server independently. Alright, so we'll have to make sure that we navigate into the server folder, and then we run nodemon index.js. But we haven't installed nodemon yet, so let's do that now. That'll take a second. And once we get our server up and running, we should be able to access the GraphQL playground, which is a nice feature of the Apollo server, is that it supports the GraphQL playground. And let's see if we've got this good. Okay, so we should be able to run our server now. pm run server. Oh, so what did we do wrong? Okay, it says unknown type launch, so we can tell if we go back to our schema, there's something we need to fix. We see right here, it's not launch, it's Quake. We return an array of Quakes. You probably caught that. Alright, so now because we're using nodemon, we're able to immediately restart, and we see that our server is up and running, and that's good. And it's running at localhost 4000, and as we said before, or as I said before, you'll be able to access the GraphQL playground, and we see that indeed if we go to localhost 4000 we can access the playground. Now what the playground is and what it can do for you we'll get into in the next video, so if you are able to get this far and everything works, then good. If not, then it's debug time for you. Anyway, I'll see you in the next video, and thanks for joining me as always. Cheers.